Okay, so next thing we're going to talk about is using square roots in a problem. So,
Did you say square roots or screw?
square roots. Okay. Square root of 4 plus 3. Okay. Yes.
That would be 2 plus 3.
That would be
Square root of 4 is 2.
right.
The answer
Or
would be
negative 2.
5.
What if it's negative 2? So
Okay.
we have 2 answers.
Would be 5. Okay. Now, when you are solving in this situation here, okay, you always assume that you take the positive of it. Okay. Now, the other thing I forgot to mention with negative square roots, okay, so I said you could not do this, okay, but you can do this. Okay. There's a difference between the two. Okay. This one up here, you're taking the square root of negative 9, which cannot be done. This, you're taking a square root of 9 and then making it negative. Excuse me.
And then that's
Okay, so in this case here, the answer would be what? Yes.
If the square root of 9 is 3 and negative 3, then how are you making it negative? Would you just make it positive?
Right.
So it would still be negative 3 and positive.
Would just be, well, in this case here, it would just be negative 3.
Yeah, but then you have like the other negative 3 because it's
Right.
still positive.
Don't worry about the other one. You're worrying about just the positive one. Okay? So in this case here, it would be negative 3. Okay? It's just like if I took okay, same concept, just now with the square root. Okay? Excuse me.
Getting a little sick?
No, just my throat's a little dry. Okay. Okay, so here we have an order of operations problem. Okay. Well, in the order of operations, okay, parentheses, exponents, multiplication, division, addition, subtraction. There is really no place that says square roots, right? Unless I missed it. Okay, but square roots are the opposite of what? In the order of operations, exponents. Okay. So we replace exponents in this case with square roots. Okay. So what we would do first, since there's no parentheses, we do our square root first, which is what? 5. Okay. So then we'd have 3 times 5 plus 4, which would give us what?
19.
19. Okay. Excuse me. Okay. Here I have the square root of the fraction 16 over 4 plus 1/2. Okay. There's a couple ways that I can do this. So I can deal with the square root. Okay. If the fraction can be divided into a whole number, okay, we can do that. So in other words, 16 divided by 4 is 4. And we can take the square root of 4, which in that case would be 2. Okay. Now, let's just say 16 couldn't be divided by 4. Okay. Just for the sake of this example. Okay. What's that, Bill? Actually, we'll just do this. Okay. So, 16 obviously cannot be divided by 9. Okay. But because the square root is over the whole fraction, I can distribute my square root to both the numerator and the denominator. So in other words, I can rewrite this as the square root of 4 over the square root of 9. Okay? Now, what advantage does that give me? I'm sorry, not square root of 4. Sorry, square root of 16. Okay? Plus 1/2. Now, I can take my square root of 16, which is, okay, take my square root of 9. Now I have my two fractions, and what do I need to do in order to add them?
Make it common.
I have to make a common denominator. Okay? Alright? Let's see if there's anything else. No. Okay, last example. Okay. Square root of 36 times square root of 25 plus 4. Okay. How do we solve this? Leah?
Well, you have to do parentheses first, so you
Okay.
have square root of 25 and 36, which is 6 and 5.
Okay.
Then you have to multiply those two,
Okay.
which is 30, and then add 4.
Very good. Okay. So, that is square roots. Any questions?